Whenever a train is traveling, it becomes contaminated, not unlike cars, bicycles, or aircraft. The NS aims to keep their rolling stock as clean as possible. This is not only for a more pleasant look for passengers, but it is also a working environment for a lot of people. Exterior cleanliness of trains is not only important for aesthetics and branding, but also for safety, as the train operator needs a clear front window and the train signals need to be clearly visible. The NS has noticed a structural issue regarding the cleanliness of their train exteriors. Train surfaces are often extremely dirty, and there is no way to quantify how good or how bad a washing location is performing. Trains are scheduled for a wash every 7 to 14 days. Their cleanliness level decreases over time, but is restored with a wash. In practice, trains are often washed too late, not thorough enough, or not at all. To tackle this problem, the NS has launched Project HURT, a redevelopment of the entire cleaning operation for train exteriors. Currently, trains are washed on a time-based schedule, which doesn't perform optimal. This can be improved by changing into a condition-based schedule. In other words, if you know which train has more contamination than the other, you know which one to wash first. A system that automatically measures and scores the cleanliness level of each train would enable this transition. Currently, contamination is measured and scored using the quality norm. This is a 1 to 10 scale where a visual comparison is made with a train exterior. Unfortunately, it is not scalable and no reliable solution. But digitization of the visual quality norm could be the way to transform to a condition-based schedule. Contamination comes in many shapes and patterns, but all contamination manifests as a darker color or hue on the surfaces. This is especially visible when comparing to clean surfaces. In order to measure the amounts of visual contamination, several methods have been explored. First, an experiment was performed to see if the amount of correct type yellow pixels in a close-up photo could be measured and then compared to the cleanliness level of said surface. It turns out that this is not reliable because not every surface has the same color, and all train surfaces are discoloring due to sunlight. Also, you don't want to measure discolorations, repairs, or damages as if they are contamination. Secondly, an experiment was conducted where the mean RGB value of photos was related to the amount of contamination. A lower value would represent dark colors, or contamination, and a higher value, bright colors, or a clean surface. No clear correlation was found using this comparison, so it was deemed not a suitable solution for automated measuring. It was found that contamination should not be measured objectively, but it should be determined through a comparison with the same surface shortly after washing. If a comparison is made to a situation where repairs, damages, and discolorations are already included, then the only difference will be the newly formed contamination. To test this principle, photos of trains and train surfaces in all sorts of scenarios have been compared. Using a software tool, all changed pixels representing newly formed contamination are highlighted and represented as a percentage of change. This shows that the principle of measuring amounts of contamination as a difference between the two photos works. So how would this work in practice? The NS has recently installed an infrared camera arc that makes panoramic pictures of the bogies of each passing train. These photos are processed to check where maintenance is needed automatically. These camera systems produce identical photos every time, and the infrared feature makes it possible to take photos in all lighting circumstances. Using similar camera systems, identical panoramic photos can be taken of each wagon to then be compared to a panoramic photo that was taken shortly after washing. It may require some warping and stretching of photos for a perfect overlay, but these are realistic and solvable issues. In summary, the condition-based washing cycle would be as follows. Wash a train, take a reference panorama shortly after washing, take a new panorama when the train passes another camera arc somewhere on the railroads, match, compare, and score the difference using automated software, and finally update the washing schedule based on the current condition of trains. Concluding, it is possible to automatically measure the cleanliness levels of trains by comparing panoramas and measuring the difference.